It says 1 o'clock, so I guess it's time to get started. So first of all, my name is Paul Jacobi, and I'm a software engineer here at BSI. And I'm standing up here tall today because I stand on the shoulders of Dave Fairbanks, Rob Brooks in the back, and Claire Grant. And so my presentation today, you can think of that as a continuation of my last presentation at the Bootcamp in Boston. So last year, I presented how to use the ESXi hypervisor to configure fiber channel pass-through. And this year, I will present how to use the QEMU KVM hypervisor with fiber channel pass-through. And if you would have asked me last year, with all the success that we had with ESXi, I would have thought at that time that it would just take a couple weeks to get QEMU KVM up and running with pass-through. But as we later learned, QEMU KVM takes a slightly different approach to PCI pass-through, and that threw us some interesting curveballs. The good news here is that all of our fixes are included in the V9.2-3 Update 2 kit. So it's all there ready to go right now. So after a couple of strikes, we finally made a home run. So let's get into it if we can. This works. Now we're not working again.
Clicker's not working.
Yeah, the clicker, somehow it was working a minute ago, but now it's not working. Advance the slides. Oh, maybe I don't have
Bottom left.
Maybe I don't have the pointer over.
Escape. Right arrow, left arrow. Maybe?
Okay, now maybe over here. Maybe now. There we go. No, now it clicks this one, and not the. Yeah, it's a hardware problem. Escape. That's better. That's.
What was the match?
I'm not sure, but now it's advancing up here, but not down. Now it's not down there. So this is the important one to advance. So the topics I have for review today is I want to take a quick review of the two different modes of using fiber channel in a virtual machine environment. We're just going to make a quick review of that, and then we're going to quickly jump into PCI pass-through mode and look at the hardware requirements and the Linux configuration requirements for configuring QEMU KVM pass-through mode. And then we're going to use the new Linux cockpit interface to define a VMS virtual machine with fiber channel pass-through. And then after that, we're going to look at the actual changes that we had to do to the VMS driver to support the new QLogic cards, and specifically changes that we had to make for the QEMU KVM hypervisor. And after that, maybe we'll get some time for some challenges for the future. Okay, so what are the hardware requirements for PCI pass-through? So first of all, I'd like you to think of PCI pass-through mode as a mode in between the bare metal environment and the pure virtual environment. So in the bare metal environment, it features a constantly changing set of hardware requirements that's very difficult for VMS to keep updated with, versus the pure virtual mode, which has fixed hardware configuration, but suffers by the use of emulated hardware. So your I/O performance suffers when you use a pure virtual mode. Versus the PCI pass-through mode, which starts with the pure virtual environment and then opens a window in the hypervisor to a specific and limited set of hardware that VMS can go out and touch directly. And by directly touching the hardware, that ensures that we get maximum I/O performance. But that's going to introduce some particular hardware requirements on our system. So for example, on a laptop here, I can run VMS in the pure virtual world with a hypervisor, but there's no way to plug in a QLogic card into a laptop. So the first thing you need to do is to start with the HPE Gen 10 system or later. HPE Gen 9 systems do not work. In fact, we tried that at one time, found that it didn't work, and found out there were lots of other people that are complaining about Gen 9 systems not working correctly with PCI pass-through. So HPE has said that unfortunately Gen 9 systems do not have there are some unresolved issues with either the hardware or the firmware issues that they do not want to get back into. But fortunately, you have your choice of using a Gen 10, a Gen 11, or even a Gen 12 for PCI pass-through mode. So HPE is just not interested in going back and digging up fixing old problems on Gen 9 systems. And you have three other options here. And then you'll need to add the required card that is supported by VMS. We support the QLogic cards in the SN1100Q, which is a 16 gigabit fiber channel card, and two 32 gigabit cards, which include the SN1600Q and the newer SN1610Q, a QLogic fiber channel card. And for PCI pass-through systems, they require use of locked memory. So when you configure a system for use with PCI pass-through mode, these require much beefier memory configuration. So you want to take that into account when you're ordering a system for use with PCI pass-through mode. And we'll talk about a little more about that in a moment. And you also need to check your UEFI BIOS settings as your first step. And you need to make sure both the virtualization is enabled and the VTD and the IOTLB are enabled. So let's look at what we need to configure a system for PCI pass-through mode. First thing you want to do is look in your BIOS, stop in your BIOS, and make sure the virtualization and the VTD settings are both enabled on your system. And I have a screenshot where you will find those. On AMD systems, because VTD is a trademark of Intel systems, AMD, they have their own name for that. I think it's either IOTLB or IOMMU. That's not trademarked. And then you will need to modify your Linux boot command line to reserve the IOMMU hardware for PCI pass-through mode. And then when you do that, you'll need to unbind the Linux QLogic driver for the device and bind the Linux VFIO PCI driver to the device. And the good news here is that if you use the cockpit interface, steps 3 and 4 are done for you automatically using that interface. But if you start your VM with a script, maybe you will have to do that manually. So here's a screenshot from an Intel system, of course, because it has the Intel virtualization technology enabled and the Intel VTD technology enabled. And on AMD system, you'll find something very similar, something around virtualization technology and something labeled IOMMU or IOTLB. You'll need to first thing you will need to do is make sure those two are enabled in your hardware. And you can also use a tool in Linux itself called virthost validate, and it will check a number of different settings in your systems for use with virtual machines. And specifically, you want to check that these two items are marked as pass. And we want to take a look at your Linux command line. You can cat that out on a running system. And you want to specifically look for the two items here, Intel IOMMU on and IOMMU PT or pass-through mode. And if you don't see those on your command line, you will then need to modify your command line. And on newer systems, you can use the new Grub utility for systems that use the new Grub2 boot. And you can use this line to add those two arguments on your command line. If your system is using the older Grub1 style boot environment, you will have to go and manually modify the grub.conf configuration file to add those items. And of course, then you'll need to reboot Linux itself to make those changes take effect. And when Linux is controlling the QLogic HBA adapter, the kernel driver in use will be QLA2XXX. But to use the QLogic HBA for pass-through mode, this needs to be changed to VFIO PCI driver. And to do this, you will need to unbind the QLA XXX driver and bind the VFIO PCI driver to the device. So if you do this in a script, you can have your script unbind the QLA2XX driver, bind the VFIO PCI driver, then start your pass-through VM. And then when your pass-through VM powers off, your script can then take a hold again and unbind the VFIO PCI driver and bind back the QLA2XX driver. This works a little differently in ESXi. ESXi only allows a static assignment of one mode or the other for PCI pass-through devices. And when you do that, you almost have to reboot ESXi to change that mode. But here in Linux, this can be done both dynamically, and you can also set it up so it statically always comes up with VFIO PCI driver. I haven't looked at the sources for VFIO PCI driver, but I suspect all it does is basically nothing. It's basically a do-nothing driver that simply marks this piece of hardware in use, so nobody else in the Linux world can touch this device. So there's no way when VMS is using in pass-through mode, it does not go through Linux in any way. It goes directly to the hardware. This driver just says hands off from the Linux side. So let's define an OpenVMS VM with the new pass-through, using the new cockpit interface. And cockpit is a graphical user interface to QEMU KVM. It's kind of similar to ESXi in that respect. So you start with a web browser. Oh, well, before we get to that, there's a specific order that you need to be aware of when you create a pass-through VM. And that is because the latest changes to the VMS QLogic driver are only available in the v9.2-3 update toolkit. So you want to start with defining a VM without a fiber channel pass-through device, a pure virtual VM. You want to then install v9.2-3 kit to that VM. You apply then the update toolkit. And then finally, after that's all done, then you can go back to your VM description, power it off, and finally add the fiber channel HBA to your VM description, and then reboot, and then you should be able to come up and see devices. So here is a screenshot of the cockpit interface. You start with open a web browser and go to the IP address of your QEMU KVM system, port 9090, and that will bring up the cockpit interface. You'll need to log in with a username and password from your Linux system, and then I think in some cases, probably to create a VM, I think you will need to use you would need to go through enable administrator rights. Let's see, how do I do this? Yeah, right there. And that will ask you for like the administrator password. And then you'll need that to do things like to create a VM. So I already have two VMs already up and running here. And we'll just create a new one here. So you tap on the create VM box, and you'll start with give it a name. You'll give it a path to your VMS ISO image file that you've copied over to your Linux box. You'll need to define some disk space for your system disk. I think I defined 50 gigabytes here. That should be plenty. And I defined 16 gigabytes of memory for my system. And you also note here that I define the operating system here is generic Linux 2024. That's the closest I could find to VMS settings. But to do that, we still need to make some minor customizations. And the first customization you will do after you create this VM but before you power on the VM, you need to use the GUI to change the BIOS mode from legacy BIOS to UE5 BIOS mode. Once you do that, you can then start the VM. However, as I was stuck there for a while, the VM gets some strange error about cannot access the ISO file. And I thought that was maybe with Linux permissions somehow, and I moved the file around to 10 different directories, and I still could not get to work. What that's caused by is the VM description enables secure boot mode. So once you start the VM, you can at least get the boot manager up and running, and you'll need to exit the boot manager, and you hit escape a couple of times, and you will get back to the EFI menus. And from there, you can go into the menu and disable secure boot mode, as it's circled there. And then once you do that, you reset your environment, reboot your VM, and now you will then come up in a way that we can then read the ISO file. Cockpit includes a serial terminal emulator that's available within a web browser. It's far from perfect in terms of VT100 emulation, but it's good enough to run the installation menu. And it's pretty neat because this all runs inside a web browser, and you don't need another PuTTY or anything like that to access the VMS serial console. It also, of course, supports the graphics console as well too. But I'm an old guy, and I always like the serial console. So I'm happy there is a way to do that without having any extra tools on your system. So then you can boot your ISO file, run your installation as you would normally, and then once your installation is up and running, you can then configure the network. You bring over the copy over the update toolkit, install it, and then once you reboot after that, then you can power off your VM and finally add the fiber channel host bus adapter to your VM configuration. And for a lot of times, we use dual port fiber channel adapters, and you will need to add both ports of a dual port card to your VM configuration. So you cannot split a dual port card into two separate VMs. They all have to, everything on that card has to be dedicated to one particular VM. And I was mentioning locked memory, and that works a little bit differently on QEMU KVM. On ESXi, we saw that before you even power on the VM, your VM description, you must check a little box that says use locked memory, or it won't even power on. Things work a little differently with QEMU KVM. Here I have two VM descriptions. The first VM is the memory status display from a pure virtual VM without PCI pass-through involved. And I've defined that VM to be 16 gigabytes of memory. But actually, since it's a pure virtual VM, it's really only using a couple of, maybe a little more than a gig of memory. And if that VM needs a little more, the hypervisor will automatically find some memory somewhere and give that dedicated to the VM. It's a little differently when you take that VM and add a PCI pass-through device. Because at power on, the VM will take the entirety of that 16 gig of memory and lock it to that particular VM. So PCI pass-through VMs, they're very stingy. They grab memory, they hold on to it, and they won't share with anybody. So that's one of the reasons you need to make sure you configure plenty of memory for PCI pass-through systems, because they don't share nicely. And that is because of various DMA operations that we have to do. In the DMA map has to know exactly the DMA map for that particular VM.
What actually defines this 16 gig, or is that just?
That is what your VM description, so you can make that any size you want.
Okay.
But when you do whatever size it is, it's going to take the whole lot of it. Whereas with a pure virtual system, you can define a giant number, but if it's only using a little bit, you only use a little bit.
And is, do you have any sort of ideas of recommendations for sizing that yet? Performance wise?
What was the question?
So, have you got any sort of recommendations for the actual size you should use?
No, because it really depends on your application and what you're going to do.
Yeah.
The pass-through mechanism itself does not consume more memory, any more memory. So it's not as if that is an attribute you need to factor in. It's really just how much memory will your system really want. I mean, we typically will configure our systems for production with 32 gig, but we also have pretty deep hypervisors, a fair amount of memory. But the key thing is you cannot oversubscribe your hypervisor with respect to memory when you're using PCI Pass-through.
And these VMs, you know, I was only creating a VM simply just to get a couple LUNs up and do some simple backup testing. So, you know, I didn't really configure them with very much memory.
Okay, so I think the answer is what you were running on your previous machine for production gigabits memory, probably similar.
Yes.
Yeah.
They're not, yeah, I get what you watch.
But you have to watch about other VMs on that same machine because you can't
Yeah.
swap the memory back and forth, whereas you could if they're all pure virtual. So what did VMS have to do to enable fiber channel pass-through using the QEMU KVM hypervisor? Let's see. Oh, one thing I forgot to mention about Cockpit, if you use the older Virt Manager desktop application to create VM with QEMU KVM, the new Cockpit interface essentially is becoming a replacement for the desktop application because that now runs in a web browser and that's more convenient for some folks, and it sort of matches the ESXi environment. So let's get back to VMS driver and what we had to do. So first thing we wanted to do in the driver is support the latest generation QLogic cards. We kind of got lucky with the 1600Q 32 gigabit card because it was nearly identical to the older SN 1100Q 16 gigabyte card. Except for, of course, for the faster speed. So the only thing we had to do is make a minor cosmetic change to the driver so it can correctly display the higher maximum speed. For the 1610Q card, QLogic added redundant dual flash ROMs. So anytime you update a flash ROM, you're always aware about if power is removed during that flash update, it could possibly render that flash ROM in a corrupted state. So with dual flash ROMs, you update your flash ROMs one at a time. And if one gets destroyed, you still have a backup that's valid. So VMS PGQ driver now has to go out and validate the flash ROM headers for both the primary and secondary flash ROMs and select the header for the flash ROM with the highest valid version. It loads the firmware from the flash ROM on the card into main memory. And then it makes a request to the controller to load and verify the firmware from main memory into its own local copy of memory. And that allows the controller to perform a security validation on this firmware blob to make sure it likes it and it hasn't been tampered with. And then all this code was developed and tested on ESXi. And all the changes here were in the initialization code for the driver, and there were no changes for the mainline IO code there. So to support QEMU KVM specifically, we needed two bug fixes. The first was to fix a day one bug in the driver, in PGQ driver, around 64-bit IO physical addresses. So anytime you put a piece of hardware in a brand new environment, you know, you'll probably find these minor bugs that will creep up. So we weren't too surprised at that particular problem. The second one is very specific to QEMU KVM in the way it configures multifunction PCI cards. And that one really surprised us. It took a while to think what was going on there. So the first time we created a VM with QEMU KVM and our pass-through card, as far as we got at the first attempt was it just hung. And we couldn't even get to log in. So we recreated our VM with a logging version of our driver. and found that the driver was ended up someplace it should never be. And we backed up to the stack to see where it came from and why it was even there. And we began to wonder, well, it shouldn't have never gone this way. The only possible way it could have gone this strange way is if it had gotten incorrectly mapped its control and status registers. So we quickly focused on in the piece of the code where we get our control and status registers for the device. When UEFI powers on a system, it scans the PCI bus for all the I/O cards and parcels out chunks of I/O address space to each card. And then when the PGQ driver comes along, it reads the PCI configuration space to find its base address registers that were stored there by the firmware. And in PCI configuration space, it allows for 6 32-bit base I/O base addresses, or in that same space, you can get 3 64-bit base addresses. The base addresses, the I/O base addresses must be quad word aligned, and that leaves the low 3 bits of the base address that can be used as flags for the device. And you must clear those low 3 bits before mapping that physical I/O space address to a virtual address. And we know the QLogic HBA is defined to use a 64 base address. And that means we need to combine bar 0 for the low 32 bits of the address with bar 1 for the high 32 bits of the address. So seems like simple to do. So that's a little picture of PCI configuration space where our base addresses are stored. And a couple of other fields to know here are the device ID and the vendor ID. And that's how we uniquely identify any PCI card. And that keys us to load PGQ driver against this particular PCI device. So we ran our tracing driver first on ESXi when we knew everything was working. We found bar 0 had a nice address in it, but bar 1 was all zeros. So we combined the low bits in bar 0 with the high bits in bar 1. We really only came up with a 32-bit I/O space address. Well, that was fine. And notice we correctly cleared out the low 3 bits in our base address because it was a 1 and now it came to 0. But when we ran the logging driver back on QEMU KVM, we found that bar 0 had a nice address and also bar 1 had a nice address. But when we combined those two addresses to a full 64-bit address, the upper 32 bits were missing. So what happened? So we pulled up the code and it was trying to do the right thing. First, it combined bar 0 and bar 1 to a full 64-bit address. So that was good. But then it took that 64-bit base address and ended it with a 32-bit mask to clear out the low flag bits, the low 3 flag bits. It worked to clear not only the flag bits, but that 32-bit mask ended up clearing the upper 32 bits of the address as well, too. And so that's why it worked just fine on ESXi, because it only had a 32-bit address, but we came to QEMU KVM and it failed because it cleared the upper 32 bits. So the fixed code uses that 32-bit mask against bar 0 to clear out the flag bits, and then adds that directly into with bar 1 to get a full 64-bit address. So when we did that, we reloaded the driver, and hooray, we get the log, and that resolved our hang problem. The driver's up and running. We're able to log in, and now we can see we got 2 fiber channel ports are online. Dave Fairbanks and I are just congratulating each other and like, oh, that was a tough one. We're almost done here. The only thing left to do, we'll call up Rob Brooks tomorrow and have him assign us some storage LUNs for this device. And tomorrow we'll soon be doing backups and doing I/O to our LUNs, and we'll be all done. So the next day come around and our celebration kind of got cut short because we rebooted a couple times and still could not see any LUNs. So we called up Rob Brooks again and said, did you remember to create some LUNs? And he's like, yeah, they're all set and ready to go. I'm like, we don't see any. And Rob, for some reason, had the idea, well, let me check the switch for you to make sure everything's right there. So he checked the switch status and found that the 2 ports on our systems were having a very strange status on the fiber channel switch. And when Dave Fairbanks and I heard that, it was like, oh, now we're kind of losing faith in our driver. Something's really wrong here. And we're trying to think what's going on. And I think finally Dave Fairbanks goes, oh, that's what's wrong. I'm like, what do you see there? It looks good to me. What do you see? And you may not be all the way from the back of the room, but there's something very strange about those 2 ports.
It's visible.
So I'll highlight that on the next slide.
You've got the fiber channel node and the fiber you've got the port and those are the same. They're not supposed to be.
Right. Both ports have the exact same widths. And so it's like, oh, well, no wonder the fiber channel switch is losing its mind here. It's like seeing duplicates. It's seeing double. So Dave and I are like, I've never seen anything like that before, you? And it's like, I've never seen anything happen to me. Never seen that before in my life. So we figured it's just got to be some garbage card. So we make a trip to the lab, swap out the card, and sure enough, the new card also shows duplicate widths. So we thought, well, maybe it's some strange Linux problem with the hypervisor. So we tried 3 different versions of Linux, and they all show the same problem with duplicate widths. And like, so frustrating. ESI works this perfectly, but we get this strange duplicate width problem on QEMU KVM. So as a last resort, I went around the back of the system, pulled 1 set of optical cables from the card, and sure enough, that resolved the duplicate width problem from the switch, and we were able to figure a fiber channel line from 1 port. So that at least verified that we had a full path from our host bus adapter to the switch to the storage server. But that kind of made us more determined to understand where in the heck are we getting these duplicate widths from. So Dave and I went back and determined to figure out what we're going to do. So we studied the driver both independently for a week, studied every possible case in the driver where we could possibly get these corrupted or overlaid or something like that. And at the end of the week, we had a conference call, and we both agreed that we both found absolutely nothing in the driver to account for this. And we're ended up sitting there totally defeated in this problem. And, we're almost ready to give up, totally frustrated. And I think at one point, it was said that just out of pure frustration, there's got to be something here that's fundamentally different here that we just do not understand. What could it be? And I remember those words, fundamental difference, kind of hung in the air for a minute. So I thought, maybe there's something there. So we need to get back to fundamentals here. Instead of going deep into the code, let's look at it from a bigger picture. So what we have on a bare metal system, you have a PCI bus attached to a QLogic card. And on the QLogic card, the PCI bus first attaches to a PCI to PCI transparent bridge. It's called a transparent bridge, basically because it just kind of silently extends the PCI bus to 2 different functions on the card. Functions 0 and 1 go to fiber channel ports 0 and 1 on the card, and they're both connected to a common flash ROM. And of course, on the newer 1610 cards, you have redundant flash ROMs there. So that all looks good on bare metal. And with ESXi, that perfectly replicates all this hierarchy in the virtual environment. Looks good there. However, that's not what QEMU KVM does in the virtual environment. So I'm like, what? You got to be kidding. QEMU KVM basically virtually breaks the card in half, configures each half on 2 separate PCI buses. Yeah, it was a real surprise. And you'll notice here that the cards now are both function 0 on 2 different buses. Whereas in bare metal and ESXi, we had functions 0 and 1 connected to fiber channel ports 0 and 1. So we thought, maybe that's something confusing PGQ driver. So we did a search of PGQ driver for the PCI function number, and we found this little snapshot of code that uses the PCI function number to determine the offset into the flash ROM for the configuration parameters. And in the configuration parameters in flash ROM, that's where the widths are stored. So since both cards were always returning function 0, it was always pulling out the flash ROM parameters for function 0, and they were both getting configured with the exact same widths. So Dave and I are like, well, I think we kind of understand this now, how we're getting the duplicate widths, but we're like, well, how do we fix this? And the first idea, just to try something, we decided, okay, we'll just try a global variable somewhere. We'll initialize it to 0. The first guy that comes through the code, he'll be function 0, he'll be port 0, and then we'll increment that counter. The next guy comes through, he'll be port 1. And we implemented that fix, and sure enough, that seemed to fix the problem. So now we had 2 ports online with different widths on them. So that now we have kind of an idea of how to fix that. But Dave and I both had some very uneasy feelings about this fix because we started to wonder, okay, what happens? QLogic has been known to have quad port cards. Would this work in a quad port case? Or what happens if you had multiple dual port cards? How you could tell multiple dual port cards from a quad port card? And we're like, we can't, this can't work. There's got to be a better way here. So we had no idea what to do, but we realized that the Linux driver must have to have the same problem. So we went back and studied the Linux driver, what it did. And what the Linux driver does, it goes back in PCI configuration space and pulls out the field called the interrupt line number, which contains the value of 1 through 4. And it's unique on both ports. And it just pulls out that value and subtracts 1 from that, and then uses that to identify the port number. And we saw that, I was like, well, that's odd, but whatever works. So we implemented that fix in our driver, and that all seemed to work for QEMU KVM. And as a last thing, we decided, okay, let's go back test this on ESXi, and it worked there perfectly as well too. So that means we did not have to have any specific code in there for QEMU KVM, conditionalize this code in any way. So this works for both platforms, for both hypervisor. And as we began to get more confidence that this fix is ready to go, and this is a strong fix to check in, I decided to send email to an engineer at Red Hat and ask him, the way QEMU KVM does this, it's a little strange. Can you give me a little background of why you did it this way? Are you going to change in the future to be more like ESXi? Because that seems to more replicate what you would see on bare metal. And luckily, the engineer did respond to me from Red Hat, and he sent back kind of a apologetic response, apologizing for the way they kind of did it this way. He admitted it was he said it was a policy decision to do it this way. And he also added, oh, by the way, other OSs have had to change their QLogic drivers to account for this as well too. Yeah, now you tell me. So I felt a little pat on the back that says, well, you're late for the party, but welcome anyway. So we implemented that fix for the configuration of both ports, the 64-bit bar fix, and the new changes for the 1610 dual flash ROMs. Those fixes are all included in the update toolkit. So let's look at a quick feature of Fibre Channel. How are we doing on time? Yeah, we got plenty of time. I just got a couple more slides here. If you remember last year, I tried to boot an ESXi system with Fibre Channel Pass-through. But in doing that, I found several deficiencies in the virtual firmware environment that ESXi provides. I was able to work around some of those and actually get it booted, but that required some very complicated steps and possibly unsupported ways of getting that to work. However, with QEMU KVM, I was pleasantly surprised when the virtual UEFI firmware came up that it provides everything ready for booting. And the two things that are essential for booting is to provide access to the fiber channel configuration utility on the card and the UEFI boot driver. They're both there in QEMU ready to boot. Unfortunately, at this time, x86 VMS does not support booting from a cluster common system disk on fiber channel at this time. We have work under investigation, and we hope to have make this possible in a future release, because even within VMS engineering, we would certainly like this to work. So I think we'll get it to work eventually, at least for QEMU, KVM, and I think eventually ESXi virtual firmware will eventually catch up to the virtual firmware that's available with QEMU, KVM, and we'll be able to also support ESXi as well.
Is that only a fiber channel restriction?
As far as what the common system did?
Yeah, because they were dropping out the
Yeah.
kernel.
Claire?
Good.
It's not a technical issue of multiple access to the disks. We haven't figured out yet how to write the error log file.
Press bell.
Oh, so you thought the dump kernel?
Oh, yeah. Dump kernel knows all about writing to DOSD and all that. But we have to figure out, right now, the dump kernel just writes to, quote, the system disk, uncoordinated with any other thing in the system. We have to figure out what to do, how to write the error log file. How to report.
You were thinking about the restriction where you would have to do this with DOSD support.
Well, we're just going to mandate you have to have a DOSD. That's the way it ought to be anyway.
That's the easy way to do it.
Yeah. And whether
That by itself doesn't solve the error log problem.
Where things, by the way, you can on cluster parameter.
I stay far away, as far away from as I get.
So one other thing I'd like to see, if you remember when I created a VM with Cockpit, I had to choose the OS type as generic Linux 2024, because that's the operating system that I found that was closest to VMS settings that I like. And I thought, wouldn't it be great if Cockpit had a selection in there for VMS and it would set all your default settings the way the VMS wants them to? So I had a quick look at the Cockpit sources, and Cockpit uses a separate open source project called libosinfo, which creates a database of operating systems with their preferred virtual machine parameters. So since it's an open source project, it would be possible to add a VMS type operating system to that list and define a set of preferred virtual machine settings for VMS. So it might be possible to do this at some point. You know, this is under investigation, but make no promise whether this will ever get done. Or, you know, maybe we could even partner with somebody to do it or something like that. So in summary, OpenVMS extends fiber channel PCI pass-through support with the v9.2-3 update toolkit. You need to start with an HPE Gen 10 system or later, and then you need to add one of the three supported QLogic adapters by a PGQ driver in VMS. And then you now have your choice of using the ESXi hypervisor or the QEMU KVM hypervisor. And of course, fiber channel technology continues to evolve in the future. So, are there any more questions? But allow me first to anticipate one question that you may have in your mind, and that's around what is the performance of fiber channel pass-through in terms of disk performance. And I'll invite you to Claire Grant's session tomorrow at the same time. And he's now collected some information that I think you will find very helpful. And I think there's some good news there. So anything else? Any other questions?
Multiple x86 machines accessing the same fiber channel disks.
Right, that's the cluster common system disk case that we are working on, but don't have it ready at this time.
Well, but even non-system disk.
Non-system disk.
Non-system disk, yes.
Yeah.
Yes.
Been doing it.
Right.
Yeah. Data disk is fine.
Yeah. Just have this, which if you bring one machine in, you should existing, you're gonna have a separate system disk.
Yeah, that's the restriction now. You'd have to have a separate system disk for each root,
But they
each system.
once they're booted on their system disk, they can access common fiber channel disks.
Right. And we still have the problems with ESXi and their firmware for booting. But it seems to be there ready in QEMU KVM case.
We've used a common data disk for months, this,
For me, 18 months.
yeah.
So that's all I have. Thanks for coming to Bootcamp 2025.